recording. Timing.
That's it?
Yep. Okay. Do we need to talk about this stuff?
Yes.
So that is us putting it together now. Starting in the back, we have 2 sets of back wheels because we wanted to try to get it to go up the stairs a little bit better, and then we noticed that this one is causing it to roll back down, so we added the second one. Then we chose to do a joint system for the middle of this bar so that you didn't have to take it completely apart to be able to put it in the box. This and this are part of our drill mechanism that you'll see in a little bit. We chose to do 2 screws in the middle because we wanted to minimize the time that it took to put it together. This is our drill system, and so the drill attaches here, the battery latches in here, and then this spins to make it go forward. This is our mounting system. This is a bearing and a bearing mount. It's mounted to aluminum tubing that's mounted to the tubing that's attached to the plate. This is the same on both sides, but this one has the gear as well. We chose to do 2 rods across the middle because we tested it and we found that it was the most weight efficient while still handling the torque well. And then as far as our foot mechanisms, we have a spring here so that when this goes in, it pops back out just like that. So the spring was calculated so that the weight of the machine would be enough to press it down while it would still come back out. So this is our quick disconnect system, and this is our threaded trigger mechanism. If we can get a drill, we can show you how to work with that. This is mounted with 2 screws so that it didn't twist. And then I'll show you how this works. Actually, can you do it so I can hit the phone?
So our throttle mechanism is made to be quickly assembled. 2 bolts is all that holds that on. This is then threaded on the drill to the mount there, where it would be tightened down, but in this case I'm not going to because I don't want to launch this off of the table. I'm going to take this, pull it back, turn it lock that in place. Because it's not latched, it's sliding backwards. But as you tighten this, it controls the speed of the you pop that out. So, let's take it. On the wheels here, we have the washers hot glued to nylock nuts for just ease of keeping them in place. We use nylock so that the spacing wouldn't change, the wheel-to-wheel spacing. I didn't want that to move. I wanted that to stay in place and be a easy stop, so we can just thread the rods through and put the bolts on the opposite side. These are aluminum rods that were threaded to M8 1.5 or 1.25 threads. On the inside, between the wheel and the gear, we have the other washer and a 3/8 nut as the spacer, and that is being used to space the gear off of the wheel because the chain needs somewhere to go. The gear can't sit flush against it. We found that will fit over the top of the threads and the rod, and that saves a lot of time and effort of trying to thread up that nut on between the wheel and the gear. We have the easy disconnects here, where you can thread these on and off for the box so it can go in. We made the wheels detachable from each other so they could fit in the box and have a wider wheelbase.
Why don't we weigh it like this?
Yeah, well,
We can
it's
just
gonna
support it.
be really hard to weigh.
You want to give it a shot? We can cut it out if we don't like it.
The only way to weigh it would be stand it up so it won't be accurate.
No, okay.
But we can show the box weighs around 1.2 pounds. We did not include that in our weight because that was not specified.
The box and the drill mechanism are both not included in our final weight. Yes, the box weighs 1.2. So, I will attach a picture of the weight with it in the box. So, I think that's everything.
That's it.
We will cut this to running it up the stairs. Yes.
Ready?
Yep.
As you can see, it gets stuck on the third one. We had to do a minor adjustment because we set it up crooked to the stairs.
Yeah.
But as you can see, it works great for the first couple. But the issue is down here, is that as I'm gonna hand crank it, as it gets, like, I'm gonna run it by hand slowly. So you can see, as it gets there, it catches and then it falls back down.
We've tried a lot of solutions to try to fix that, and this was the closest one to working.
But we kind of ran out of time on getting the final solution to that. I think if we had more time to test it, we would have been able to get that rest of the way fixed. The main concern there was that we didn't have a ton of time to get our initial design fixed after we had the parts we ordered get in and had it constructed. So,
Some of the things that we focused on for the design parameters were this piece. We used it to try to make it the fastest way possible to make it still fit in the box, because this obviously has to be longer than 8 inches, or 16 inches.
16 inches.
So we installed this as a way to be able to just loosen these 2 bolts and then fold it in half, which you can see on the video of us putting it together. This was our idea for the drill, the threaded drill mechanism. And so as you thread this bolt in, this is usually up here. As you thread that bolt in, it turns the drill on. And then since this is behind here, when you pull this out, it acts as a quick disconnect mechanism.
And allows that to come forward and off of the trigger.
So, other things that we did are we did not put a screw in here to save time when putting it together. We designed the plate to split in half so that it would fit better in the box because it was really tight the other way. So we had to redesign that. We installed bearings here, 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 there. I don't know if you can see that one. And then also in each of the wheels and underneath the tubing on both of the back wheels. We had to install a chain tensioner very, very last minute just on our way over here because the chain had loosened up as we tested it. So
we were it was looser than we wanted anyways to start with. We ended up in a weird spot between like in a half link. It needed an extra link. And if we pulled an extra link out, it would be too tight. And we were concerned about it putting the torque on it or breaking the sprocket because it was pulling it at an angle because it would be too short.
As far as weight parameters, we decided to keep the plywood for the wheels because we didn't want to have to split the wheel into multiple pieces to print it. Because PLA is a lot lighter than wood, we tried to print as much as we could, but we decided that risking it falling apart was not worth a few grams, basically. But we did decide to print the plate at 5% infill because that was going to be the lightest option that we could do. We also printed all of these back wheels in 5% infill with PLA, as well as this gear. So all of those were weight reduction ideas, as well as this was originally supposed to be steel, this little thing, aluminum, and we decided to print it instead on both sides.
Purely for ease of manufacturing.
Ease of manufacturing and weight.
It would have worked. The original idea, the reason that these bushings are in here, they're low friction and they're ribbed, so only about a third of the surface area of the inside circumference of that ring is actually touching the rod, so they were designed to be low friction bushings, and those would have been inserted into the original metal piece. We went with aluminum rods for here, everything, pretty much when we used aluminum instead of steel because it's lighter and has enough strength that it's not something we need to worry about. This is really the only thing we use steel for, and that was just purely because it's like 10 gauge or 16th, I don't remember exactly what it is, but super thin steel, and the ease, it would have been a lot easier to weld that bolt on to the back, and the other option would be to have to glue it because you can't weld aluminum to steel. So if we had used aluminum, we would have had to find some other way to attach that nut onto the back of that plate.
Anything else about that? We talked a lot about it during the setup.
We went with bolts for the axle and not the center, not having an axle going all the way through because it saves a lot of weight. We basically used a split axle, so instead of having one axle going all the way through, we used two that transmit the torque a lot better because they're offset, so it helps to transmit torque. We were able to split the axle and leave the bearings and everything mounted so it's attached to the frame here. Saves time and weight that way. The bolts are also easier to assemble and put together originally on the manufacturing side, not the assembly side. Saves a lot of weight because the axle going through the middle would add probably half a pound because it'd have to be, I think, like 15 or 16 inches, and that adds a lot of weight. We went as wide as we could without being exceeding
The box size requirement?
Or size design, so we went as far as we could go width-wise to add stability, so where we could still take it down and put it in the box pretty easily without having to take apart everything. Yeah. We had thought about going with 4 rods. You can see the holes for them here and here. We found that that original thought, once we actually got it laid out, we were like, yep, they'll hit. We laser cut the wheels before we finished the assembly just because of time, and we didn't have a lot of things that we could do early on, so we wanted to get those cut before it got busy. But we figured And as you can see, having those extra holes doesn't really impact anything. It just takes away weight, which is not a bad thing for this project. So those are still, it doesn't severely impact the strength of it, or yeah, it's just a hole to save weight at this point. We also considered adding another bar here on by the feet up here to stabilize it and help keep them together. But once we tested it, we realized that we didn't need it, and so we stuck with the two to save weight because it worked for the most part. That part of this, the whole stair climb works without it. We went with some plastic bearings because we had them. I had been fooling around with some of those to start with, printing them. They use 4.5 millimeter steel balls on the inside. The only issue is if there's any kind of torque against, not on the axis like that, it will pop it apart and the balls will come out. But when it's something like this that's in line and cannot move, they're perfect. Granted, if it spun for like an hour and a half, it'd probably heat up and might have some issues there, but for now, for as short of a time as these run, it's not really an issue. So it saves a little bit of weight there. What else? We went with tension springs instead of compression springs up here because we found that it was really hard to find compression springs that were long enough and not too strong. The ones we found that could compress to small enough for the thing to come all the way in and clear the edge of the wheel were like 45 pounds or only went like a half an inch. So, and we needed something that would extend farther and be lighter. So I think it was about 3 pounds per spring, because that way the overall weight of it should be under 7. So 3 pounds per spring gives us about 6 pounds of extension force on each one. And so that way when it's in that position, the weight of the stair climber compresses them without any issue. I did that math by just simple static stuff. I didn't account for friction, but I added in my calculations, but I just kind of went lower on the lower end to account for it. These are low friction linear bearings. That was the goal there with the bushings, and lubed. We used dry silicone lube to lube up the aluminum rails to help with reducing the friction.
As far as the project as a whole, I definitely think the SolidWorks part of it was incredibly valuable. I think learning how to make the assemblies and the sub-assemblies and put them all together was something that we need to know as engineers, and so that side of it was definitely incredibly helpful. As far as what the project was, I wish we had a little bit more freedom when trying to figure out how to improve it, but I understand why it is what it is. It was incredibly difficult, even with the parameters that we were given. So I think it was incredibly valuable. I think a lot of people learned a lot more about the makerspace as well, which being the second year class is really helpful considering the next 2 years that we have for a lot of more difficult classes with difficult projects. So I think that was definitely a good thing. And then there's also just the experience of learning how to build things and learning the mentality of the manufacturer. When you're only designing something, it gets hard to understand how different things work together, and so getting the hands-on experience of building it yourself is something that definitely helps put engineers in the shoes of a machinist. So is that everything?
I think so.
Okay.